here's the homework for the next level of logarithms is, do you understand the properties of logarithms to be able to simplify it or write it as one logarithm? So here we're going to follow some basic rules. So the rule is, if you have two logarithms and you're adding, the bases have to be the same. If that's the case, then you can multiply the inside parts. Now, if you have a number in front multiplying, it can be written as an exponent inside. So I'll do that first. So the 3 can be written as an exponent inside. The 7 can be written as an exponent inside. Then, to write this as one logarithm, adding means you're going to multiply them together. Here. That's the exponent 1/3. Now the cube root of 64 is 4, so I can just write that down. And then when you're subtracting, it means you're going to divide. So 4 divided by 12. Number 3. This 1/2 is in front of all of it, so it belongs to both. So I'll do what's inside first. Write what's inside the parentheses as one logarithm. So because they have the same base and you're subtracting, you can write k to the 9 divided by k to the 3. Now, when you're dividing and the bases are the same, you can subtract the exponents. Now this 1/2 will be written as an exponent inside. Now there's already an exponent. So when you have that, you're multiplying them together. And 6 times 1/2 is k cubed. Here we have log 8. And this becomes the exponent for what's inside that logarithm. Again, log base 8. 3 becomes the exponent for what's inside the logarithm. Exponent laws means that we're going to multiply. So 3 times 5 is 15. 2 times 5 is 10. C cubed, and then 7 times 3 is 21. Then when I write this as one logarithm and I multiply, I add the exponents. So 15 and 3 is c to the 18, 10 and 21, that's 31. So again, the number in front is the exponent inside. So this is log a to the 5. This is log, and it's the square root of b, if you want to write it that way, or b to the 1/2. And this is log c to the 4. All of them are common logarithms. They have the same base. So I can write it as one logarithm then. So we have a to the 5 times b to the 1/2. And I said that's the square root of b. And then subtracting means you're going to divide. And in the denominator would be c to the 4th. Here again, the exponent 2/3. Here again, the exponent 5/2. So I'm going to simplify that first. So 27 to the 2/3. Give me a second. Hey, I'm there. Okay. Oh, no. Now that. Thank you. Oh, I got it. I picked it up. Oh, yep. All right, I'm back. Anyways, 27 to the 2/3. The denominator is the cube root. So the cube root of 27 is 3, and then 3 squared is 9. So just do it in 2 steps. So the denominator is the root. So the square root of 4 is 2, and then 2 to the 5 is 32. And then when we write it together, we multiply 9 and 32 together, and that's 288. Number 7. So the 4 is the exponent. Inside the parentheses, I'm going to write that as 1 logarithm. So to write it as 1 logarithm, the 2 is the exponent. And for 3, that's the exponent of y. Adding means you're going to multiply it. So I'm just going to do that all in one step. V squared and y cubed. And then when you're subtracting, and the base is the same, we have a fraction. In the numerator is x to the 4th, and then in the denominator is v squared y cubed. Number 8, I'm going to simplify what's inside first. So ln and ln, same base. Subtracting means I'm going to divide. So a fraction line, it'll be 64 over 8x cubed. 64 divided by 8 is 8, so I'll just do that. So it's 8 and then x cubed. And then this 1/3 is the exponent on that. So it's 8 over x to the 1/3. So the cube root of 8 is 2, and the cube root and the 3, they divide out, so it's like 3 times the third. They undo each other, so it's just x. So it's ln 2 over x. Here, start, the 1/2 belongs to the exponent inside the logarithm. The 3/2, same thing. We're going to distribute the half and add. So when we're adding, it means that whatever answers I get here, they're just going to multiply together inside. So I'm just going to do it in one. The square root of 9 is 3, and that's root x. Here, the square root of 4 is 2, and it's 2 cubed, so that whole thing is 8. Multiply this together, and you get 9 over 2. Maybe I should have just kept it as 1/2 to make it easier to simplify. Because then the next step is I need to multiply it. So 3 times 8 is 24. So when I add the exponents 1/2 and 9 over 2, I get 10 over 2, which is x to the 5. Here, the bases are the same. So I have log. I'm adding, so I have 4x times x subtract 3, but the 2 is the square for the x minus 3. Honestly, you could leave the answer just like that. Turn the page. How about the other direction? If it's 1 logarithm, do you have the skill to expand it completely? So the first thing I look at here is the 4th root. So I can write that as 5w plus 2 to the quarter. And once I have an exponent, that exponent can be written in front. Then everything that's multiplying, I can then separate. So the challenge here, though, is we have 5w plus 2. So remember, in this direction, adding and subtracting, I have to let it go. There's no property to expand that. If it was multiplying, I could do it. So adding or subtracting, I can't expand it, and I let it go. Number 12, dividing I can do. So dividing means I'm subtracting. And make sure you use parentheses. So it's the numerator subtract the denominator. Make sure you write ln and then ln again. If I see an exponent, I can do something, and multiplying I can do something. So ln 3, so it's 3 times r squared. So ln 3, when you multiply, you're adding. Remember this, I can't do anything with r subtract 8 because it's adding and subtracting, you have to let go. But I can do something with that exponent. So that exponent can be written in front of the logarithm. Done. All right, number 13. So I'm going to expand this by first subtracting. And I'm going to write b to the 1/3 right away. Next, I look at multiplying. So I have log base 5a plus log base 5b to the 1/3 minus log 5c to the 4th. So now I have all the adding and subtracting. The last step is to look at the exponents. So 1/3 I write in front as a product, and 4 I write in front as a product. And that's it. Number 14, do you see adding and subtracting? So one thing I can do to help this is to factor it so it's now a product. So what two numbers multiply to negative 24? And that, I was going to go 6 and 4, right? It's 12 and 2. So plus 12 and minus 2, those are the ones that fit. And now that it's multiplying, I can then separate it into two logarithms, adding. That I can't go any further with. Number 15. So I see the exponent first, so I have to handle that first actually, because then I can get and handle the dividing part. That 3 will stay on the outside. And then I can, dividing means I'm subtracting. Here we have 2 times j, so it's log base 2 base 4 plus log j base 4 minus, now do you notice this 5? That can be written in front of the logarithm, and now it's fully expanded. All right, number 16. Let's expand this. So first I'm going to write this as 3m n to the 8 to the 1/2. Then I understand that that goes in front. That 1/2 will stay in front for all of it. So I'm just going to put parentheses there. And then just do the work. So it's log, it's base 6, 3 plus log base 6 m. And then make sure the exponent 8 is in front when you write it down. Oh, yeah, and it's all adding because it's multiplying. So notice 3 times m times n, that's where the adding comes in, and the exponent 8 in front. 17. So I'm going to take care of the 2 first. I'm going to put that in front. Then I'm going to write 2 parentheses, and I'm just going to expand it as I see it. So 7, and then g to the 9, because of the 9 in front, and then 5 in front, and the h. If you wanted to, you could now take the 2 and multiply everything out. $18. So I see dividing, so I'm going to write this as log y to the 1/2 subtract log 4y plus 8. So the first part, the exponent 1/2 goes in front, Now for the second part, in order for me to expand it, I got to factor. So I can factor a 4 out and get y plus 2, so that to fully expand it, I can now write log 4 plus log y plus 2. So that because I'm multiplying, I can expand it further with adding. Notice I put parentheses over everything that's subtracting because the whole thing belongs to the denominator. Number 19. So I'm first going to write it exponentially. So I'm going to write x to the 4th, y to the 7th, to the exponent 1/3 over z. Then, for a logarithm, the property, I notice the 1/3 can be in front. And then the fraction line means I'm subtracting. I can expand this further. The 1/3 only belongs to the numerator. So I'll put the 1/3 in front. And then x to the 4th becomes 4 in front. And x plus 7 in front. And y. And if you wanted to, you could multiply that 1/3 out, but not necessary. All right, number 20. So to do number 20, I need to write it as a product. This is going to go way back. This is a difference of cubes. Do you know that one of the zeros here is 2? Because 2 cubes subtract 8 is 0. So we can use the 2. And it's 1u cubed, 0u squared, u, 0u, and negative 8. And then I could divide synthetically to understand what's left over. So that's u squared plus 2u plus 4. So this is u minus 2 as factors, and then u squared plus 2u plus 4. Now that it's factored, you can now separate it. All right, you did your homework. GMath, over now.